Hello everyone and welcome to Tech Effect. In this podcast episode, we'll be discussing a topic that's gaining interest day by day, being widely by experts and business owners online and in multiple conferences. The topic is
AI.
Artificial intelligence, that's correct. We will talk about the challenges, use cases, maybe we'll touch a bit of the building blocks and the latest advancements in this field. So potentially everyone knows who I am. For those that don't, I'm an expert in audio and video testing and leading the efforts to ensure the accuracy and consistency of test result data. Also managing some benchmarking projects in TestDevLab. So joining me today is our dear guest, Alvaro Laserna Lopez.
You almost say it right.
Almost.
Yeah, it's just like you put the accent in the second A, so you say Alvaro.
Alvaro. That's how you need to pronounce it. So Alvaro is artificial intelligence guru. Can I call you that?
You can try.
Yeah, so he's been working in the research and development field for multiple years right now and has gained extensive experience regarding the automation field. And obviously, if we talk about artificial intelligence, then there as well. So how are you feeling?
I'm feeling good.
You're feeling good?
I'm happy to be here. So
I hope you will enjoy the discussion and it's going to be really great. So let's start off by getting to know a bit better about you. Mm-hmm. It's going to be a really serious question right now.
Okay.
You ready?
Go for it.
Okay, so the most important question is, do you like pineapples on a pizza?
Damn, that's a hard question. I mean, I sometimes like I don't usually order it, but if someone does it, I will eat it, and I will be like, yeah. I mean,
if it's free, right?
It's free.
Exactly. Yeah. So, what's your background in the IT industry, in the field?
What is the background?
Yeah, and how did you actually get here today?
Okay, so my background in IT is I didn't have a real background in IT previous to joining TestDevLab. So at first I studied physics, actually theoretical physics. I have like this specialty on that when I made a degree. And then I went to astrophysics. Well, to be more technical, to technology, science and technology for space stuff. So I did that master, and then I thought I like developing. I had a very good friend that he's a developer. He's been for quite some time, and he has like, he doesn't have a company, but he's like one of the people that were in the board, like at the beginning, and he had like a very good life. He worked from home. So, like even before COVID times, he was working from home pretty much all the time, and he worked. Sometimes he was like busy, sometimes he wasn't. It's kind of like in all ITs, it's kind of like that. It goes wave to wave, and there are some days that you pretty much don't do almost anything and just drink coffee.
So you actually like the fact that you can have a free time and then you can work again and probably remotely as well in that time?
Yes, and it is not so much related to being physically at some point from 8 to 5, but rather is more goal focused. So kind of like you have to deliver this, do it whatever, like however you want, but deliver it.
So the friend was as an inspiration to switch to the IT field.
Yeah, I mean it wasn't like, well, yeah, it was for switching. I'm just thinking like, because it's not like I was annoyed by physics and astrophysics. It's just like I wanted to learn about this new thing, and I like the idea of working remotely and being more focused on these goals rather than actually being on a place for these kind of like periods of time during like the week. And so I finished my master's degree. I presented the dissertation, and like the next day I was flying to Latvia. So because I had already the job position, like, well, the internship. So
you had the internship at this particular company or other company? Oh, at this particular company. Nice.
Yeah, like.
But why you didn't search for IT companies in Spain or any other Europe country? Why Latvia?
Well, that's a funny question. Well, not funny, but I mean, it's just like my ex-girlfriend used to be, well, is a Latvian girl. So I thought like, well, and also like Baltic countries are kind of known for IT stuff.
Yeah, especially
good
Estonia.
company. Yeah, Estonia. Yeah, and then I was searching for IT jobs, and I was actually searching in Facebook, and one advertisement from TestDevLab appeared in my in that feed, and I was like, okay, I will send an email to these guys, and yeah, like they gave me a task. I told them, well, I didn't have so much experience, but I would like to try out. I did it, and then I had like, I'm not sure if it was then or like before, but I had a interview with Andres and Ervins, which was very weird because I was searching and I knew that they were like the CEOs of the company and they were interviewing me. And I was like, okay, is this like a regular thing? By that time, the company had like around 70 people.
Oh.
So it's not like they were just 4 people. There were already like quite a lot of them. And yet it was like the CEOs interviewing me. And then I got to know that I was going to be one of the first foreigners to be working at TestDevLab, and they actually changed the policies of talking at the office in English instead of Latvian.
So everybody's talking English because of you?
Pretty much.
Wow.
Well, I was the first one that made the switch from Latvian to English and to make it more international.
Okay, and what was your first task?
My first task was it was actually started with automation. So we had a project for like a car part company.
It was automation for mobile or desktop?
It was both.
Both.
They had both. But at the beginning, actually, and also it was API. I was mostly checking API testing.
Oh, okay.
By that time, and it was Ruby code. So I didn't have any idea of Ruby, but I learned and at the spot. So and then they noticed that, well, I was doing corrections of like code that was written and code that was flaky, and well, my line manager by that time, he well understood that I was okay at developing. Yeah, I was good, and so after the trainee,
It's 3 months.
It's 3 months.
Yeah, 3 months.
They kept me. You see.
Yeah, you're still here.
Yeah, I'm still here, and then I started switching to like I switched to a project that was written, like they had automation for Java. It was for a banking company, and after that, well, I started writing like my own framework, which was Java based. This is TestUI, and
I remember TestUI.
yeah,
That was really nice.
yep. And then after that, well, I started developing some sort of grid for mobile devices, and it kind of got a little bit still, even though I still have the code, and I think it could be a cool implementation for the future. And then I switched to a different project. It was Python based, and well, I wrote, because I knew already some Python because of in physics, one of the code languages that we learned was Python, which was interesting because when I started learning Python, it wasn't so famous. It wasn't like the thing by that time. But then machine learning stuff came in, and well, and mostly because the mathematical, like matrix operation with Python got really fast, really fast. And then, well, like data scientists started using that.
And when did you encounter like the first time the AI? Because you've been working here for how long?
In TestDevLab,
yeah.
4 years.
And in IT industry, so it's 4 years.
Yeah.
Okay. And your research development.
Yeah, I'm head of research and development.
Amazing, long road.
Yeah, it went like trainee, junior automation, intermediate automation, senior automation. I actually worked on development projects such as Lodero and Appimation, so I was a developer there, mostly on the back end, but I also helped out a little bit with the front end, even though like it was just a little bit, because in Lodero I was only for 3 months, I think. but still it gave me an idea of how development works from the development side, and not only from the testing perspective, which is like very different. How they try to integrate one to each other, and the best thing for like QAs is to actually be like as close as possible to the developer, so they are aware of write your unit test, don't deploy anything on production without actually doing like a kind of like regression shoot and a smoke shoot, and all those kind of things. So if you work together, things start to work better. But and that's the cool part about having a testing company with also like other software development now companies associated to it, because then the software is very tightly connected to the QA part, and that makes things evolve as they should.
What's your experience with artificial intelligence?
Okay, so
so it's been 4 years.
Mm-hmm.
For how long have you actually worked with artificial intelligence, with AI?
Fully work with it, I've only worked this last year. Okay. Because for previous years I only knew it in kind of like more theoretical way, and like I learned some stuff by reading through it, and
so in simple words, what is AI?
Well,
in simple terms, let's say, I know what it is, but just for viewers.
Well, what is AI? AI is it's pretty much any algorithm that can perform logic in a way that a human could do it. It's kind of like more like about the level of intelligence of a system, because for a system to do something smart, it could be something simple, like you make an input and then you get an output, which is the answer. Like, is this black? And then you go to the color, extract the color, and you say like, well.
So it's basically if we have machine learning.
But if we have like machine learning, like that's another thing. Like if we have machine learning algorithms, then it goes to predictions. So it goes through some mathematical models, and they are different kind of machine learning algorithms. Like they're for example,
what are the three main, like, because they in categories, there are three main machine learning probably algorithms for AI, right? It's just first that comes to my mind is learning, reasoning, and potentially self-correction. So it learns and self-corrects, right?
Yeah. It depends on what do you need to use that algorithm, and you will use one or another, because it doesn't make sense to use, for example, like convolutional neural networks to predict the stock market. I don't know, like it just, the one is kind of designed to make to analyze the pictures, for example, like images, and then extract the information out of them, and then you can use like typical support vector machine models to do predictions for big data analysis. And it's kind of like you just use different machine learning algorithms to.
Can you use them simultaneously in a parallel, for example, multiple algorithms?
You could actually like fed one algorithm to another. You can like chain them to understand about the context, or to do like different kind of analysis over the same data, and then you pass it one to the other. Like for example, in TestDevLab we have this algorithm which is VQTDL, and like we use one part which is a convolutional neural network as I look for feature extraction. So it kind of like.
So before you start going into details, okay, what is VQTDL? So let's say in simple words.
Oh yeah, sure. So VQTDL is deep learning algorithm,
okay,
designed to predict image quality.
Okay, so it's something around VMAF and BRISC and
VMAF is a full reference algorithm. VQTDL is designed to predict the quality of an image without a reference.
Okay, and WikiTDL is based on
deep learning algorithm, which is this convolutional neural network. And after that, it goes to a transformer encoder, which is kind of like the part that we train to predict the scores. So it kind of like changes, as I said, like you change one to another, and then you eventually get like whatever you want to get out of it. And yeah, like of course, in computer science, you run several things at the same time to get whatever you want.
But who creates the AI?
Who creates the
Yeah,
AI?
who creates the actual AI, and where do you like can start with this creation? Can like every developer just start to create it?
Well, anyone could research about frameworks that are already written, and you can go through very good tutorials on like well, YouTube or a web blog post, and they have GitHub code, well, some code written there that you can just put it in your computer, install the dependencies, so kind of like
Just a simple straight setup, right?
yeah, it's a simple straight setup. I mean, as long as you know the basics of programming on those languages. This is why I suggest to learn Python, because a lot of these machine learning algorithms are written in Python, and like these like the two most famous frameworks are PyTorch and TensorFlow, and most of this stuff, or at least for deep learning, are written there.
Okay.
And then well, you download that, you install the dependencies with the command line, and then you can even run it. And there are some examples for image recognition, so you can recognize like is this picture a cat or a boat, and it actually, you will put it there and you will get it is a boat or it is a cat, and it has a really high prediction rate.
Okay, so regards the WikiTDL, just a sneak peek to the further episodes. Let's not dive deeper with you into the subject, right? Since we'll be discussing the WikiTDL later in the later episodes of Tech Effect.
Mm-hmm.
So let's maybe go further with the AI. Yeah.
All right.
So if we're talking about AI, why does humans actually need it? Why do we need to simulate the human processes?
Well, because we want not to only replicate the way we think and we apply logic, but we want to improve and specialize it in different areas. The problem with us as handling data and handling interacting with the world is that the interface that we have with the world is our hands, and we are our body, and we are kind of slow at interacting with it. In terms that if you put that in a machine, in a computer, and you specialize it in something, it will go like so much faster. Like the time for computers goes much slower than the time for humans, because we don't perceive reality so fast. But this is when you specialize the algorithms. One thing that I don't like when people say like, well, will there be like human-like robots that will do everything that humans do?
Yeah, that's first expectations from everyone. They always want to understand that it's going to be like, oh, they're going to retake the world or something like that.
That doesn't make like any sense for me, at least, because, and this is kind of like, could you make a car with the shape of a human? And you think like, well, physically you can make a human go far faster than 50 kilometers per hour, because like legs and physics, and it doesn't work like that. So if you want it to be fast, you will put it wheels, and you will specialize the machine to be able to run faster, and also to make turns and go through the road, and also to carry people, because if it's a human and you put just a person over the robot, it just looks ridiculous. It's not comfortable. And so that's why you specialize machines to make a specific job, which means if you want to make an AI that is able to drive from point A to point B, like with a car, so you make like autonomous vehicles,
Yeah.
you don't have to make the vehicle know about economical situation of I don't know, like China.
In this particular example, basically we can use artificial intelligence, AI, inside the development, right? But how about testing?
About testing, okay.
So for example, you said we have this car, right? We have artificial intelligence, it's learning, it's correcting itself. But how does it stand in the software testing world as well?
Yes, but so AI is very wide in terms that how do you apply it and what do you do with it. So if we are talking about trying to understand the data that you get out of testing, because you get a lot of data, such as, well, you make a test and you retrieve, for example, the web page contents of it, and you just save it every time you test it. And then every time it has a faulty thing, you annotate it as it is faulty, but you still keep that page source, and then you can have like a lot of data and a lot of labeling, that this test was good, this is bad, and then you can actually potentially feed that into a machine learning algorithm.
So again, you can predict, is it going to be good or is it be bad?
Just by having data and then doing analysis over that data. And that doesn't have to be like, as I said, like deep learning, machine learning algorithms. They can be like other kind of machine learning algorithms that work perfectly fine.
So for software testing, we can use it to analyze the data.
Yeah,
and like potentially predict the problems.
But that's one of the usage. Like the other one is that if we have one of the industries that are very hard to test are video games and things.
Especially in metaverse.
Yeah, especially in meta. Yeah, and that is like even harder.
That's another topic to touch.
Yeah. So and the problem with like testing that is that you don't usually have like physical buttons, and the way of interacting with it is very like it's ambient, and you navigate through it, and then you see things, and then you act over it. But it's not like on a web page that you click the cart button,
and you have ID for everything.
And you have IDs for clicking over everything, and there are drivers to be able to control them. So what do you do in that case? Well, one of the ways to deal with that is to actually build an AI algorithm that will analyze the surroundings of like
the whole screen of the computer.
The whole screen of the computer. Well, you don't need to have the computer itself. Well, you could feed the frames that are fed to the computer, so it's kind of like a middleman that you get directly, so you don't have to render them. So it's kind of like you fed it directly into the AI algorithm. It will see everything as you see it, and then it will predict like what to do, where to go. You can create maybe specific routes, but then you need some sort of AI to assert that things are displayed as they should. And to be able to do that, you have to actually make very good AIs.
I know that people make AIs for driving games.
For can you elaborate?
For example, Rocket League, they're making the AI to understand how to drive it, and they train it.
Oh, okay. Yeah, but I mean,
and for example, for you, potentially you can create for Forza or any other type of specific game where you need to drive a track, and they're creating the AI. You can see on YouTube a lot of videos for that, where they're learning how to actually drive the corners and around all the lap to get the best time possible and the best actual speed in the track.
Yeah, but in like there are two ways to do that, and well, one of them is that if you have the information of the road itself, like what are the edges, and that you kind of like from the APIs of those games, the game should have that information. So like it knows this is the edge of the road, this is the other edge of the road, this is how it curves. So it's not so
and there's a complex map as well there.
Yeah, but it's not as complex as if you didn't have that information. Like if you only have the image itself, which happens with like autonomous driving, because when you have autonomous driving, you often don't have the information of the road and the limits of the road, so you have to predict where are those by analyzing the images and then checking for edges. And actually, this neural network will predict where are those edges and where it curves, where it has like a signals.
How does the driver takes the turn? So they knew.
That's more logic out of like. That's
But still, the Tesla, I think, uses this type of thing to feed the algorithm. No?
They use AI to predict the where other things are going to move later. So kind of like if a car is there and then it's here and then it continues moving forward, then it will pretty well. And also there is a road going here, then it will maybe turn that position or turn the other position. And it happens with pretty much like all the objects. It could be bikes, it could be people, it could be whatever. And it has to take all those variables into account. It's complex logic, but
regarding the complexity, and I was reading online some discussions about AI in software testing, and what I saw was that people are talking that either the tests are really simple, that AI just doesn't bring much value to it, or the tests are so complex that and domain specific that AI can't handle them. Is this true?
It is half true. So the problem with
so what's your perspective on this? Yeah.
So you can right now the technology I don't think is there to be able to successfully implement AI in some of the cases. I mean, we implement AI in our testing at TestDevLab, but like that's a very niche.
To what type of testing? To
audio video test.
Oh, okay, that's pretty niche, as you said. Yeah.
Yeah. So, but if you want to test like UI interactions, then that's a whole nother world. But you can actually use AI for some stuff. Like it doesn't seem like you are using AI, and it's fine because, for example, you have a web page. And then you have to assure that all the text is within the page and is not overlaying like some other object, or that you are seeing it completely, or that the text is correctly written. And that's visual, because if you are looking only at the like the tree, the actual source code, you will see all the text perfectly fine. But if you see it at the web page, it could be out of the screen.
Okay, but if we're using the AI, okay,
yeah,
continue.
That's what I mean. So you could use I think is called Tesseract, which is a Google algorithm to extract text out of images. And then what you can do is assert that those texts are displayed correctly by visually analyzing the content. So you can do assertions of like the web page that things are displayed as they should, and that's using AI.
Okay, that's depending on AI. But how do you test the AI itself? Do you even test it?
How to test the AI itself?
Yeah.
I mean,
because we can't know for sure that it's going to be 100% correct, right? You somehow need to develop it, so it potentially has a place for software testing as well.
Yeah, of course. I mean, for any AI, you train it and then you test it, and there is always like this percentage of the data set that you have from all the images that you are going to train the algorithm. Then you have a tiny portion that you use it for testing that your algorithm actually works as it should. And then you can see what is the percentage of accuracy of your algorithm. It's kind of like, yes, you train it, and then on unseen data, you see, it has predicted that this text is this text in a 99%. And then you say like, okay.
And what can be done to improve it for 100%?
Well, 100% is
it's not going to be really, we know. Let's say you tested it, it's 90%. How to get that? I mean, 2%, for example. How to get better?
You can get 100%, but that only means that the testing data set is not big enough. Because I mean, if you get 100%, that means that it's good in your testing data set, but that doesn't mean that if you add new images to the testing data set, that is going to predict the 100. You just said like within that boundary, it's perfect.
So what are the, let's say,
And yeah,
what are the boundaries or percentage to say that this algorithm is, it's good? 90 to 95, 95 to 98?
It's, well,
Or you can't say it like that.
You can't really say. I mean, we say depending on the case. Depending on the case.
Okay.
Because for any algorithm, any AI algorithm to be good at predictive things, the data that you have for training and for evaluation, it has to be very well picked. It's not like you can take just random images, label it as you want, and then just apply the algorithm and train it, and it will be like, okay, this is already good. No, you have to spend a lot of time, and it's like most of the time just handling data and filtering data.
So the core problems with AI and software testing is that you need to filter the data, or
you have to clean the data.
Okay.
Yeah, you have to very precisely clean the data, and this is actually how it works with human perception and human brains. That if you for your whole life, if you have lived in a cave, and then you only see like a bunch of things, but then just within the cave, and then you go outside the cave and you start seeing like cars, phones, you won't be able to understand anything at all, because you haven't been trained on you haven't been seeing those.
You don't have the reference for them.
And even like it's even better to use like the language analogy. If you at your very early age, if you have the influence of your parents and they speak, for me, Spanish, and then I grow up and I try to understand like English. The thing is, I have some bias of how do I understand language, because I've always from the beginning I learned Spanish in a specific way, and so the logic of the one language and the logic of another are sometimes a little bit different. And well, which means I will speak an English that is a little bit weird because I formulate things a little bit differently. And when I switch from one language to another, I'm kind of mixing them, and the logic gets a little bit fuzzy, and then you say weird things. So it's kind of like, and machine learning algorithms work similarly. If you're training with one data, and that data it is only containing some sort of information that is biased because you have these boundary conditions of your reality, which is in this case the data set, then the predictions are going to be biased, and they are going to predict things that are good within those boundaries, but when you go outside, they might be not right. So it's kind of like also another analogy will be gravity. So Newton's gravity was perfectly fine as long as you weren't measuring gravity in like very massive objects. And so it works as long as your reality is within small objects. But once you go to black holes, then Newton's gravity doesn't work. And that's because you haven't really looked at the algorithm, which is in this case just the equation of like gravity by Newton, in a wider range of data, which is in this case black holes or superstars or whatever. Superstars as like big, big, you know? Not Lady Gaga or something like that, you know. but yeah. And that's why I mean that you have to do a lot of science on the data itself, and then you can actually build good AI algorithms. And that's like the problem with autonomous driving. Like you need to be careful what to add into these AI algorithms to be able to make the car drive better. And we've seen regressions on vehicles like Tesla that over an iteration then start working a little bit worse. And I mean, we don't know why exactly. Maybe they just made some mistake on the code, but it could be just that they have a data that is actually making the predictions work worse instead of better.
If you're adding a new data to algorithm, right, you don't know how it will impact the overall thing itself.
You won't know precisely how it will work with unseen data.
Yeah. Okay.
And that's the problem, because they have a lot of data coming from cars that they are saving in data.
And as a human being, you can't really think of all the possibilities that can happen.
Yeah.
Because there are endless count and amount of possibilities that could go wrong and could go good.
Yep. And still, like, this is not something that is unique from artificial intelligence. It's something that happens to our brain as well. When we see something that is so different from what we've seen previously, we also can't really make logic out of it. And this happens with the film industry. If like at the very beginning, when like superheroes were introduced to this like a film, and they started to be like better and better, when we were watching like super speed human like movie at super speed, it looked kind of weird. I can think of, like, for example, Man of Steel from 2012.
Yeah.
And by that time, it kind of looked a little bit weird, because I think before that we haven't seen anything moving so fast.
Because humans are skeptical about new things that come in.
Yeah, like it just, like, you can't compile it. It's kind of like, this is weird. But then over the time, once like more films came out and displayed this kind of characters doing these sort of like impressive things, then it become a little bit more normal. And now watching actually when I rewatch Man of Steel later, it looks better and better instead of the other way around, which is an interesting thing. So people get used to things once we learn, once we add that into our brains, our data. And if we will to show any film to a person from the 15th century, they will be like, what is happening here?
So recently you traveled to Amsterdam, right?
I did.
And it was a conference about AI?
It was a conference about AI.
What are the latest advancements there? Let's say like that, yeah, advancements, and what's your look on them?
So, well, this conference, it was interesting in a way that they were mostly focused, at least they showcase companies that were going there and showcasing their products. They were more about data. And I mean, we've talked already about like the importance of data.
So yeah,
It makes sense, but they didn't really showcase much of like actual implementations of AI on the industry. There were conferences because they were talking about these sorts of things, and they were talking about that during the talks, but they weren't really showcasing anything like mind blowing on the product side. So what I want to say is that the AI, like the importance of AI, is now on the data itself and how you handle data and how you modify it and work with it. But then, as what are the advancement, like the key points of this? One of the things that most engineers are trying to work on is to make more efficient algorithms that weight less, like they are smaller in size. These models that does the predictions, they are smaller, and so they can do faster predictions. They need to do less computation, and they predict with the same accuracy. And this is a hard thing to do, because normally when you reduce the size of any model, you lose performance. And not performance, but you lose accuracy of the algorithms. And
just behind every algorithm, we have a huge data set.
Yeah.
And when you narrow it down,
it's not like, this is a misconception of I think many people think about AI and how the logic works behind the thing that they are looking at the data and then making logic predictions about the new data that you have, and that's totally
that's not right.
That's not right.
Okay.
So when you have like, just think about how the brain works and how we think that, well, a window is a window, or a computer is a computer. We are not really recalling a previous computer that we've seen or a previous window that we've seen, and then we are saying, okay, this is a window or this is a computer. No, what we are doing is that we are analyzing each part of the thing that we are seeing. We are checking, like, okay, there are edges here. It it has a handle. It has a window. Or it has a like a thing here, and then we build the concept of it just by doing these sort of filters, and then predicting what it is. But we don't really search on our memory data set to say, like, okay, this is very similar to this other example, and so this is a window or this is a computer. And what I meant with that is, once you've trained your AI algorithm, the data set just goes away. You're not any longer looking at data. So it only goes to this algorithm.
You use data set to create the filters.
Yeah,
then you just throw out the data set, but you keep the filters.
Yeah.
Nice.
Is just keep the logic, but forget about the data itself.
Because you have the logic itself. Why do you need the data?
Yeah,
makes sense. That's nice.
So yeah, it's kind of like you feed that image, then it goes through like different filters. It says, like, well, it has this, or about that.
So there's complex algorithm set. It goes through, and then its final decision comes out.
Yeah, exactly, and that's it.
How do you see view like AI benefit? How does AI benefits the human in the long term?
It can go sideways as well. Because we don't know what are the limits of AI and what things can potentially cause. It can derail the whole society in ways that we can't even predict, because AIs can be created for good, but it can be created for very bad things. So
we need to be careful there.
Yeah, of course, and there are starting to appear more regulations over how to use AI and ethical AI and things like that, and that's something that and necessity right now, because things can go bad if they are employed by bad actors.
Yeah, regarding the bad, I know that I'm not sure. Do you know the Cambridge Analytica?
I do not.
You don't know who was Cambridge Analytica? It was on Netflix. There was a docuseries. You can check it out, where they actually used data analysis to influence people on how will they make a vote for the president.
Oh yeah, I've heard about it.
Yeah, check it out on Netflix. It's really nice. I'm not sure how it's called, but if you write the Cambridge Analytica, it will come out.
Yeah, but you can make. You can also make. Yes.
So if you're a bad person, you can take and analyze all the human beings. You can narrow it down. What are they doing? What are their interests? And use it for a bad or good movement in the future.
Yeah, and you can make the AI algorithms to actually make predictions that like work very good, like for sales, for advertisement. You can make people addicted to stuff just because they are targeting so good. They are just selling good, but they aren't being like ethical about it. So they are making people to consume more and more and more, but they don't really need it, and they are actually making them sick.
So there's really a thin line between good and bad.
Yes, because like for these AIs, you aren't training them in an ethical way. You aren't telling them, okay, sell this, but if this person is actually being addicted to that, just stop doing that. You're not doing that. They are just selling it. They just want to sell more, and that's why, like, you treat the data. If you treat the data to only being able to perform an action like as efficient as possible, that doesn't mean that it's going to be as ethical as possible. In a lot of cases, it won't. But that's when you are trying to do social behavior, and you are trying to control the social behavior, and that's something that comes within marketing. Marketing is a bit of like politics in a way, but that's why it's good to have control over these platforms, to understand how the data is handled, and then to make action over those. And it is very complex, because where do you draw the line is something that is being drawn right now.
How about metaverse? Do you
Um,
think there's going to be a role in the future? Because we know that metaverse right now advancing, right? The Meta is trying to create an online solutions, and everyone is like jumping on it. Everybody wants testing and development. But will this increasing interest in the metaverse will bring the AI there as well?
For any technology that arises, the part that I like the most is that the knowledge gets farther and farther, and we get to know more things and more things, and how to work stuff in a better and more efficient way. But this doesn't mean that the product will get in the way that we predict that it's going to go. And what I mean with that is that I'm not fully sure if the metaverse, as we think about it now, is going to be a thing in the future, in the near
It can be
future.
completely different how
Yes.
we describe it right now.
Yeah. So, and the usage of it, because we think that we will use the metaverse to just get there and be in another world that we will navigate through in a different way. But we could potentially do mixed reality or augmented reality to help out our labor on different areas. And it is true that some works are being done there, like Microsoft with their HoloLens, that you can potentially in the future have meetings with people in other parts and have their avatars popping out there, and you can modify things in the 3D space, and all that stuff is very interesting. But on the testing perspective, is very complex as well. So,
Nice.
but yeah, about like where is it going, the metaverse? I don't know.
That's a hard question.
I don't know. Like
Let's be real.
I hope. Well, from my point of view, I actually am looking forward to some breakthrough that reduces the size of these glasses, that makes it like for the wider public. Because right now you have like these headsets, they are expensive, and they are not.
We have augmented reality.
We have augmented reality, yes, and it's true that Meta associated.
Just for viewers' sake, what is augmented reality, and what's the difference between augmented intelligence and artificial intelligence?
Well, they are different things.
Yeah, like, just explain them.
Okay, so augmented reality is pretty much you are on the real world, you can interact with it, but on top of it, you get things overlaid, such as I don't know, like internet window just pop in there, or an avatar there. It's like Pokemon Go, like that was augmented reality, and you have a Pokemon showing up like on the street, but this through your phone.
Exactly.
But and then you have virtual reality, which is you are completely immersed on that new reality. And AI works on top of that, because you need to be able to recognize surfaces, you need to be able to put things on the perspective that it needs to be. And then for doing those complex operations, it's not like if statements all over the place. You need to make like logic that is a little bit smarter just than regular coding logic. And to be able to do that, to be able to create these complex scenarios, you use AI. And it also happens like on on special effects, like for lightning surfaces, and then like being able to represent things as loyal as possible to the real world. They are using AI in some of those algorithms, and uh, yeah. So then, if we go to augmented reality, um, the key is to reduce everything and to make in and to pack it into an everyday thing that everyone can
As
carry.
you mentioned earlier, the glasses, for example.
Yeah, the glasses, but something that is also like cool to wear. So it can't be just the bulky glasses that just weights on your nose and is it's kind of like.
I remember Google was creating Google glasses. Where did they
Yeah.
actually go? I haven't heard anything in a while.
Yeah, I don't think they went anywhere.
They didn't win anywhere?
Yeah, I'm not sure, but I think
because there was a hype around it, like, hey, we have glasses, and now it's like, where are they?
Yeah.
Microsoft, Google.
Yeah, and now is Meta the ones that are trying to do that, and that's why, like I said, like they partner with Ray-Ban and they are making these glasses that actually have some sort of augmented reality, and that's kind of cool because if you can potentially have something that is wearable that represents something, overlays over reality,
It's
that
like
you can interact with it. It's and it could be used for very simple things. Like we don't have to make a new world that represents like everything. We can use it for simple messaging, that you have the glasses and then you have a pop-up window, and then you just with your hand you do like that. I mean, it will be a little bit weird at the beginning because maybe you have people walking around and saying like this, and they will like, "Are you Italian?" No,
no, I'm not Italian.
I'm just popping away the notifications, and then
It's like, imagine you're walking down the street and you're like, oh, doggy.
yeah, like things.
If you can't have a real dog, you just put on glasses and you have all the dogs you want.
Yeah.
So what do you think is the key and main takeaway from this conversation we had today?
Well, the key thing is that AI, we need to think AI as something that is being developed for very specific purposes. And it is true that we can like pack them together and do like some smart things, but if we want to apply AI to the real world, we should make it specific to specific actions and to be able to release our workload from repetitive tasks to be more creative. And I think like that's like the future of humanity and the future of humans and technology, is that we focused on creative work, and computers focused on repetitive tasks, and that, so pretty much in the future, what I think, or the prediction that I think that will be, if nothing goes sideways,
South.
if everything goes fine, all the works that will be in the future will be about creative things, like film.
People
music.
need to use creativity. We are designed for that.
And exploring also, like science is going to be always there.
Yep.
I think science and art are kind of like the two pillars of the future. And then
it's getting continue, sorry.
and that's and well, a lot of new career paths are going to arise from that, from the fact that we are going to be more creative on maybe the virtual world, the augmented reality world, that we are going to still improve maybe AIs because of data science and such. And the film industry, music, I think that's going to be like the main focus. And we are actually seeing that right now, that creative jobs are like getting more and more, and that and being in the entertainment industry is a big thing and is growing every year. And that's,
but to be for humans to be more creative, I think we need to in the world change maybe the learning model for the kids.
It is changing. It is constantly changing.
But not in all countries.
Not in all countries, yes, but that's the thing. Like I know a lot of people that work on the teaching, as teachers on early age and also middle school and higher institutions, and it is impressive that every couple of years the learning models they change, because things change and the way that we interact with the world is different, and the way we also understand brain and psychology and all those things they change. And so that's again like what I mean with AI and how to make better AI models. We have to, from the very beginning, we have to choose the data and how we train the data. In this case, kids. Sorry, I'm treating kids as as computers, but I mean the AI algorithms, they are designed as the brain. That's why like neural networks, neural networks in programming are called like that, because they are designed as our own neural networks on our brain. And that's like we are trying to replicate the learning models on humans on computers. And that's why the learning and teaching is so important and at early ages, because the way you teach the young generations shapes the future so much.
That's true. That's a really nice quote there.
It gives you a bit of a concern, because when you get older, you get your knowledge and your connections, your brain connections.
You have your skills and advance these knowledge set. You have the reference for all the world.
Yeah, and it's
But
so hard to get
a new perspective on things. So that's why we need for kids to shape a future. They have a new perspective on everything.
Yeah,
great. That's
and,
great.
And well, when people talk about like living longer and longer and longer, well, the only way to make that happen in a good way is that after like some time you just delete your memory completely, like, because otherwise you have so much bias and you have so much things piling up from that that connections that you've made from younger ages that doesn't work anymore, that you don't work as you should. It's kind of like piling up errors on your code. They just start piling up so much that eventually you just, what do you do? Like when you code, you start making a web page and you don't really know how to make a web page, but you still like do it. And then you get to a point that, okay, I have to really scale up this thing, but it's impossible because the ground base is bad, is not scalable. And so it's better to just throw that out and start almost from the beginning, just with the idea that you have on top, and then continue from that. And that's why like it's you have to really encourage new generations to be better than you, and they will be better than you will ever be. It is what it is.
Okay, I think let's wrap up this thing. Thank you, Alvaro. Very big thank you that you came here from Spain. And thanks everyone who tuned in, listened to this particular discussion. I hope you liked it, that we talked about a bit of AI and touched a bit of different subjects here and there. So yeah, it was very insightful discussion for me.
Thank you,
I hope that for viewers it is the same. And if everyone enjoyed listening to this podcast, feel free to follow us on Spotify, YouTube, or any other social media that we're in. Let's keep advancing your skill set and knowledge set, and make sure to check out the previous episodes, and see you at the next episode. So thank you. Thank you, Alvaro. Thank you.